Hello everyone, welcome to the seventh lecture of this series on fundamentals of structural analysis. So in our previous lecture, we have seen how an additional support is making the determinate structure to a indeterminate structure because we have an additional I guess unknown force here, right? So now we will see that if we have an additional you can say support, or if we have a indeterminate structure, how addition of an internal hinge or development of an internal hinge between the structural element, how it converts the indeterminate structure to a determinate structure or determinate kind of structure, right? So we'll see a very small example or very simple example to understand this. So what we will do, let us take the same example that we have taken in the previous lecture. So this is my cantilever beam, right? And we have a roller support here, correct? This was the we can say example. So we have a, suppose we have a let me draw it here. Suppose we have a load P or W, whatever you consider, correct? So this was the previous condition that we have. So this is my point A, this is my point B, okay? And if we see this distance from A to P is, you can say A, and this distance from this point, suppose this point we call it as suppose C, okay? So this is suppose C point, okay? So from C to B is B, correct? Now if we have an addition, you can say if we provide an internal hinge here between this particular, so suppose this is my point D and this is an internal hinge, okay? So earlier if you see, earlier this was my cantilever beam, correct? So here if we apply any load, this fixed support was able to keep this particular beam stable. Maybe it is able to keep it stable, right? Then we had provided one additional support here, so which was not required. So this is a redundant support, so it has become a you can say indeterminate structure. Now if you see, if you keep a internal hinge here, suppose we have not provided any you can say support here, but we have provided an internal hinge. So how is this actually? So suppose this is my wall, we have a wooden block fixed to this wall like this. This is the first condition, right? Okay, this is the first condition. So this is a fixed support. Now what I have done, suppose I have created a hinge here. So now this portion of the uh, uh, block is able to rotate in both direction. Okay, it is able to rotate in both direction. Now if you put a load here, what will happen? It will go down, so it is not a stable structure. So in this case, if we provide a support here, which is restraining this you can say what should I say, it is restricting the this particular edge of the block to move horizontally or to move vertically. So now it is stable, right? So basically what is happening, whenever we are adding an additional you can say when an internal hinge is being developed or internal hinge is being provided, so what is happening there, an additional what should I say equation we can develop from this particular point. Now what is the equation? If this particular node or this element, this second part of the beam is about you can say allowed to rotate, so that means here at this point moment is 0, because we are not restricting the joint to, you can say, move, or joint to rotate. As there is no restriction about for rotation, so that means there will be no moment, right? It is rotation is allowed here, right? So as we can generate an additional equation here, which is moment, summation of moment equal to 0 at this particular point, so it is converting our indeterminate structure to a determinate structure. And if you do not do, if you do not do any you can say mathematical calculation, if you just think about like a layman, right? You just think about like a layman, that if it is like this, there is no support, it will fall down, right? This particular portion will go down, so it is not stable. We have provided a support which is restricting this particular you can say part to move horizontally or vertically. So in this case, now it is stable. If we even put some load, it is stable, right? So what has what we understood from this, that this support is not anymore an additional support. This support is actually required to keep it stable, right? So that's why now it has become a determinate structure. So now what we will do, we will do this mathematics here, and we will try to understand how it is actually happening. So now what I will do, I will just mark this. Suppose this is at b by 2 and this is also at b by 2, correct? At the center we have provided a hinge, okay? So internal hinge. So now what we will do, we will divide this portion and this portion separately. So we will draw the free body diagrams for these two portions, okay? Part 1 and part 2, correct? So if we draw the free body diagram of part 1, okay, I should say part 1, then it will be, okay, this is the beam from, I will just name this, suppose A, sorry, A, and this is my D, correct? What are the supports we have? This is fixed support. So this, if I just say this is my X, this is my Y, and the perpendicular one, okay, leave it. So this is my AY, this is my AX, and there is a moment MA, correct? There is a moment MA, fine, okay? So, and this end, as this is internal hinge, so only the rotation is allowed, but this vertical or horizontal movement is not allowed, right? So in this case, we will have two components here. We will have two components here. So one will be the vertical component, so I can say dy, and another will be my horizontal component, I can say dx, right? Okay, so now this is my part 1. If I draw the part 2 here, if I draw part 2 here, so from part 2 what we get, now if you see here, part 2 is this portion, okay? Part 2 is this portion. So we have something like this, okay? I will draw here something like this, okay? So here at this particular point we have point B. So here I have, as this is a roller support, so only you can say only constraint is the only restriction or support is along the vertical direction, right? So we have by, okay, and if you see at this B point, at this point B, sorry, point D, now is in this particular point, what we have done, we have given the vertical and horizontal this direction. You can see the direction. Now at this point it should be opposite to each other, so it should be like this and it should be like this. So it is my dy, it is my dx, because when in this particular point, basically in this particular point there is no support, it is a single jointed beam, right? Only we have provided a hinge, right? So that we can allow rotation here. So in this case, in real scenario, there will be no reaction we will get from this particular point, right? But as we have divided it into two pieces, okay, to solve our equation, to do the mathematical equation, so what we have done here, uh, we have provided equal and opposite forces. So when we'll be adding it together, it will be ultimately 0, right? One more thing that which is not there, but I'm just drawing, that the moment which will be developing here is basically md equal to 0. Here the moment which will be developing, okay, I'm not talking about any direction, or I'm just randomly giving the direction. Okay, so here it will be md equal to 0 because there will be no moment at all. So I have just drawn that the moment at this particular point will be 0 because here rotation is allowed. So now if we write the equilibrium equation, summation of fx equal to 0 already we know, and ax equal to 0, so I'm not writing it at all, okay, because there is no horizontal force, so ultimately this is going to be 0, right? If I draw the summation of fy equal to 0, okay, and I'm considering this whole length as a single length beam. Okay, let me draw the one mistake I have done. I need to draw this force also here, E. Okay, so this distance is a, this distance is b by 2, okay, and this distance also b by 2. Okay, so if I now write the equation for the whole section, okay, this portion you really leave now. So first case will be ay plus, okay, by here equal to 0. No, not equal to 0, equal to, it should be equal to p. You see in this case actually here ay by, it should be equal to the vertical load which we have, p, right? This is one equation, this is my equation number 1. And if I take summation of moment about a here, so from here what we will get, because forces only fy and fx only we have, right? Now moment, if we take the summation of only moment that we have, summation of moment about a is equal to 0, then we have ma, okay, why ma I am writing positive, because if you remember earlier also we discussed that these moment and these forces are my positive, you can say with positive sign, right? So here the ma, still I don't know what will be the direction of the moment, so here I'm just assuming that ma is this way, positive, so I'm writing positive, right? ma. Now p into a will also generate a moment here, right? So and it will be this direction, along this direction clockwise, so sorry, about this direction, so clockwise, again it will be positive plus p into a. Okay, now if you see this by, the top by reaction will generate a moment here which is anti-clockwise, and it will be by into a plus b, right? So minus by into a plus b, this is the second equation. So this particular thing we have already seen in our previous example, and we couldn't solve because here if you see the unknown, we have ay, by, and we have, what is the unknown, ma, right? Three unknowns, right? Earlier also if you see here ay, by, and ma, we had three unknowns, but how many equations we have? Only two equations. We are not able to solve it. But here now, as we have provided this addition, I can say internal hinge, we got another equation which is summation of moment about d equal to 0. You take any of these, suppose here moment about d at this particular part 1. So in this case, if you write it here, it will be ay, if you see here ay into a plus b by 2. Am I writing it correctly? No. Okay, let me, or okay, I think we can take this easier one, this one. Okay, we can take this one. How will be taking it? It will be, if we take this one, then it will be, I mean, this point part 2. part 1 also we could take, but here we have more complexity. Let us take this part 2, so it will be easy. So if we take part 2, then what will happen? It will be by, say, this direction, and this is negative basically, right? So minus by into b by 2 equal to 0, right? by into b by 2. There is no other force which can develop moment at this particular point. So this by b by 2 anti-clockwise, so negative, is equal to 0. So by equal to, what will happen? This will go this direction, so 0 into this, it will be ultimately 0. So now we got an third equation, by equal to 0, right? By equal to 0. Now if we substitute in this, so from from 1 we can say ay plus 0 equal to p, so ay equal to p. We got another solution, ay equal to p, by equal to 0, right? Two things we got. Now what we need ma. So if you see this particular part here, we know by equal to 0, so this particular part will become 0, right? So what we have, from 2 and 3, and here I should say from 1 and 3. Okay, so from 2 and 3, if we replace by equal to 0, then ma plus pa equal to 0, so ma equal to minus p into a, right? So that means the moment ma which we are showing here, the direction will be like this. So it is very, actually that's why I have said that we are now considering like this sign convention, but after getting it the result, you will understand how it is actually. So basically, if this is a fixed support, okay, if this is a fixed support and you are applying a load here, okay, so the beam will bend like this, right? So there will be a resisting moment like this at this particular point, okay, so which will be opposite direction. So that's why now by the sign you can understand now that this ma which we are writing here, the resisting moment, which is actually providing us stability here, okay, at the part 1. So I mean part 1 of the beam, so this is basically minus pa. So now if you see, as we have added an internal hinge in the structure, so due to this an additional equation we got, okay, and we could solve the unknowns ay, by and ma, right? So now you can understand that if you have a indeterminate structure, if you can develop or if you can add an internal hinge somewhere without, you can say, I mean somewhere means some at some location, due to which the stability will not be disturbed. So adding the internal hinge here, the stability is not disturbed because we have this additional support here, right? So now what happened, this support is not anymore additional or not anymore redundant, it is also has it's what should I say, it is also working as a support to provide stability, or you can say means of stability of the structure, right? So by seeing itself, simple structures, maybe in complex structures you need to do some mathematics, but in simple structures like this, some simple structural elements, by seeing itself we can understand whether there is a redundant support or not. So now hope it is clear to you how adding a internal hinge can convert your you can say statically indeterminate structures to a determinate structure, right? So here I have explained you in a layman language, and now mathematically also we have seen that how it is converting a statically indeterminate structure to a determinate structure, right? So I hope it is clear to all of you, okay, about the internal hinge. So we will see another example in our next lecture, okay, and we will try to end this particular part, and then we will jump into we will move forward with our other topics, right? So this is it for today's lecture. We will do one more you can say example in our next lecture, and we will try to understand the you can say application of internal hinge, right? So thank you and see you in the next lecture.